Welcome back to this channel for practice problems for actuarial exams. Here you have information about places on the web where you can find things that tell you about me, the first one, and about how I teach actuarial science and actuarial program at Illinois State University, where I am the program director. Note that I use this redirect service, smarturl.it, and then after it you type a / and type the word that leads you to what you want. So if you want to find me, type in Jedi. If you want to know how to pass actuarial exams, just type pass. If you want to find this YouTube channel, pass actuarial exams. And I promote the method of studying, which I call BTDT, which stands for Been There, Done That, which is the way you should feel every time you look at an exam problem while you're taking an exam. Because there is so little time, 5 to 6 minutes per problem, that when you look at a problem during the exam, you must know immediately what to do. And if you don't, you are not prepared. And if you are trying to figure out what to do by thinking logically, you are not prepared, because the thinking should be done before the exam. During the exam, thinking is the last resort of the unprepared, and it usually doesn't work because there's no time. The thinking has to be done before the exam, and yes, you must memorize important formulas and important concepts. You must have done so many problems that you instinctively know what to do. You should be doing a lot of practice problems and taking practice exams under exam-like conditions. This is problem number 201 in study note for Exam FM. This is a problem about swaps. And you are given the current spot interest rate curve for various maturities. T is the time and RT is the spot rate for that time. And we go from a quarter of a year to half a year, 3/4 of a year, and so on up to 3 years. Raphael has a 1-year loan for $1 million, which has a variable interest rate that resets at the beginning of each 3-month period. The interest rate will be the spot interest rate at the beginning of each 3-month period. Raphael enters into an interest rate swap where he is the payer with the characteristics of the swap exactly matching the loan. Determine the quarterly swap rate that Raphael will pay. So you need to figure out from these words that what he is getting is somebody is paying him the variable rate and he is paying a fixed rate. So he becomes a fixed rate payer. Okay. Now the loan is at a variable interest rate. He will be receiving those variable interest rate payments in the swap, offsetting his loan payments, but he will be making a fixed rate payment in the swap. And one very important observation is that the swap is settled in arrears. And that means that we can use the standard formula for the swap rate, for the fixed rate of the swap. Although the rates that we will obtain will be quarterly because of using a quarter as a unit of time in the swap. The payments are quarterly. So, what is the rate based on the information that we have? Well, the payments are at time 0.25, 0.50, 0.75, and 1. So the rate will be 1 minus P1 over P.25 plus P.50 plus P.75 plus P1. And these times correspond to the times of payments in the swap. And P's are prices of zero coupon bonds maturing at the time named with a value of 1, their prices today. We are given the spot rates, so the price of a zero coupon bond maturing at a specific time will be just 1 plus the spot rate to the power negative time at which we are doing this. And that will be simply the present value of a payment of 1. So 1 minus P1 is 1 minus 1.0192, and that's the rate for 1 year, this 1.92% that we're using here. And we're doing the same for time. At the bottom we have P.25, P.50, P.75, and P1, and we're doing these calculations for all the times 0.25, 0.50, 0.75, and 1. And you may wonder, well, but we're doing the annual rates here, how do we get the quarterly rate as a result? But the quarterly rate comes from the fact that we are using present values of zero coupon bonds at times of the payments. So effectively, the time of the step from 0.25 to 0.50 and 0.50 to 0.75 and 0.75 to 1, that's the unit of time for the interest rate. Because note that this formula by itself does not have interest rate in it. It has the values of zero coupon bonds. So how do you determine what unit of time is used? And the steps between those times of maturities of zero coupon bonds are the time periods that we use. So the time unit is the step, and they should be in equal steps because that's how swaps are arranged. So this comes out to be 0.0047612, but the answer that they're asking us to give is in basis points. What's a basis point? It's 1/100th of 1%. So this is 48 basis points, or 0.48%. Remember that this is copyrighted material, and also problems published by the Society of Actuaries are their property and reproduced with permission. Solution, of course, is mine. And I wish you good luck in your studies and on the exam.